My name is Anna Eglund. I'm the graduate advisor for all of the in-person graduate programs for civil and environmental engineering. Some of you have maybe already been in contact with me over email or in a meeting. And if you haven't, please reach out after we wrap up our session if you have more questions. We can always set up a one-on-one meeting. So as far as our agenda today goes, we have Professor Brett from the environmental engineering area, and then we have Professor Hussein from the hydraulics and hydrodynamics area. And they're both going to be giving you kind of a short presentation on each of those areas. I know oftentimes we have a lot of students who are trying to decide between the two. And then we'll have time for questions at the end. So please come with your questions and be ready because I think this is a really valuable opportunity to ask those questions one-on-one with the faculty. So with all of that said, I will introduce Professor Faisal Hussein from Hydrology and Hydrodynamics.
All right, thank you, Anna. Hello, everyone from wherever you are. I'm Faisal Hussain. I'm a professor at Civil Environmental Engineering. I focus mostly in the water resources area. So without further ado, I'm going to get started on my screen sharing and share my sound. If we have time, I want to show you a video. I hope people can see my screen. Anna, let me know if it's popping up. Okay. All right. So, as mentioned, we have kind of two subparts to this grad info session. One is hydrology and hydrodynamics, which is what I'll talk about. Make sure you have enough time to ask questions. And then Professor Brett will follow me after I'm done. We'll talk about his environmental area. So I think, rather than showing a lot of text and equations and all that, I personally prefer to just show you a lot of pictures. So we'll start with some pictures, right? Pictures are always great, I think. Just so it gives you a better feel of what our program is like. So here's a picture from our hydrology hydrodynamics program. Here's Professor David Sheen. He runs a drone class, remote sensing with drone making, and he's releasing a drone. Not a grad student when done with after graduation, but it's a drone to, kind of map the ground features and some problems that he's studying of the ground. Here we have another of a professor and a student of the coast of Chile, looking at some coastal hydrodynamic stuff of lake. Here we have also, because we are hydrology and hydrodynamics, we also do not just, freshwater stuff, we also do coastal, ocean, sea stuff. So here we have Professor Jim Thompson. He throws these buoys out in the ocean to measure some stuff about the oceans, the salinity and all that. We also study snow. We have Professor Jessica Lundquist, and I'll show you the pictures of all the faculties and what makes our program studying snow. So there's a lot of field work involved. So this is for snow hydrology. Here we have another professor, Professor Becca Newman, with one of her grad students in a nearby lake sampling, I believe, the lake bottom for some legacy contaminants. And she's looking into the water quality aspect of this, which is very critical. Then here, we, which is my area actually, we do a lot of remote sensing sensors. We try to see how hot or warm a certain region is or what kind of quality it has without really being in direct contact of it. It's an example where you see some thermal infrared imagery to see the heat signature of this. Then there's a lot of field station work going. I think this is from Professor Jessica Lundquist's work in Yosemite National Park, setting up some stations to be ready for the coming snow season, I believe. This one is also interesting. We do also a lot of international work. Our work we do in our program is of global nature. So this one is in the Mekong River in Cambodia, studying rice and arsenic contamination and also the lake dynamics in that particular region. So just a picture there. So, basically H&H, hydrology and hydrodynamics, I think it's lots of fun. Here you see a picture, as you can imagine. This is again from one of our hydrodynamics faculty. They dyed the water as it, in the river as it met into an estuary and the ocean to study the plume and some ocean waves there. So it's pretty fun. You don't get to see ocean colors that around the beach. They become like candy floss type of color where you literally want to drink the water. We don't recommend you drink it, but it's fun to see that. This kind of experiments we do. So essentially, what is hydrology and what is hydrodynamics? There's like a quick definition. So in this area of a graduate program in CEE, you'll be exposed to hydrology and hydrodynamics. Hydrology is all about, how water is naturally distributed, its properties, and how it's moving around and all that. Hydrodynamics focuses more on the movement of it. It could be on land, it could be on, rivers, it could be on oceans and coastal regions. So it studies the theory of movement. And together, they give you quite a formidable preparation to study water-related problems and get a job in that field. As you can see from this presentation, we keep having these disasters on and on that kind of have a water-related implication to it, whether they're hurricanes and flooding and all that, and they're causing a lot of economic damage. And recently, our department actually we kind of did a strategic planning, and we have some grand challenges now that our program tries to assess. So there are three grand challenges. So the first grand challenge that you see at the bottom is designing for a changing climate. So a lot of the stuff that you'll get to learn in our H&H program, the courses, exposure to seminars and the faculty's research will address this grand challenge. And also I should say, especially in the Northwest, we don't have enough civil engineers, to be very honest. We need more, as you can see in this slide. There's another one example. You have inundation flooding due to hurricane landfall. You might remember Hurricane Harvey. This is in Houston. So this would address our second grand challenge, creating resilience to natural hazards. So a lot of us faculty through their courses and research are addressing this. Then many of us look into water supply, irrigation, dams, reservoirs, stream restoration. This would be addressing building sustainable infrastructure, which is another of our grand challenges in our program. So typically, you take courses in our program, you might find relevance for like utilities, or we try to address issues that are up and coming as far as addressing the problems faced by utilities. So here's an example of Seattle public utilities where we get the fresh water from. So you need to think about all kinds of things, as in hydrology, snow, water supply, water treatment, which Professor Mike Brett's area and his group of colleagues in environment will be able to address. So there's a lot of real world implications and relevance to what we're providing in our H&H hydrology and hydrodynamics area. So you see the examples here. So just that. And then there's a lot of lab work too. So we have some labs here. So we have this lab called Harris Hydraulics Lab, where you can get to do some bench scale experiments of, some of the infrastructure you might want to build on a river, or dikes or levees or dams and all that. And you get to do those experiments on a smaller scale and see how it would respond to the forces of water. And we also try to make sure that in our courses, we expose students to softwares or tools that are industry standard, where industry has a demand for. So here's an example, HECRAS, but we also expose students to other kinds of tools that we think has a lot of market value in learning those things, so you can be better positioned for a job. This is our faculty, about 10, spanning a wide range of expertise. We're all pretty fun, I think. We love to jump. As you can see here, there's a picture that I wanted to show you. You will see some of us are pretty efficient in jumping. You see Professor Erkan Istanbuloglu, kind of like Iron Man style. He's kind of keep going up and up and up. I'm not a very good jumper, by the way. Let's talk quickly about like courses. I'm not going to go into the nitty gritty of courses per se, because a lot of the information is on the website, and you can always ask our advising folks here. Anna is here of specific courses, but the website provides a lot of details. If you go to our website, you'll probably find something like this, where we have some like core courses we recommend you take, especially if you're in our coursework program, the professional master's program. Then we also encourage you to take some elective courses to build some breadth and expertise in other allied areas. So for example, in hydrology on the left side, there are some courses you can take. Hydrodynamics, fate and transport. There's kind of three like sub areas you can specialize on if you want to. But the bottom line is we try to be flexible as much as we can to address students' need, but we do want to make sure that you all have some core expertise when you graduate with that UW CE degree seal and have that quality and brand name attached to your diploma, right? So there's about that. And then if I wanted to put all the courses kind of like in a big picture way, so if you think of this water cycle, I'm showing you what's happening to the way water moves around in nature. These are some of how the courses will fit. So there's a course called Physical Hydrology that it's open to seniors as well as grad level students. So you'll be exposed to where you'll study the water cycle, rainfall runoff modeling, how to do physical models of the rainfall processes as it falls on the ground and becomes runoff and all that. There's a course we offer on data analysis. It's very much skewed more towards water issues, but you learn a lot about programming, data science, and all that. It's a required course. We make it a core course. There's groundwater flow we do, which is taught. So you need to kind of have that expertise built on transport and how the water is going to flow underground. Then we have a course on sediment transport. Rivers carry with them a lot of sediments and they go into the estuaries and the oceans. Then we have fate and transport. So you'll be kind of in the environment. Contaminants are moving around. You need to have a better handle of that, how to model it. Water management is a course that I teach. How are we managing our water? Mostly our surface water through dams, levees, irrigation systems and all that. And we have a coastal course, waterways for the coast. And then there's a hydrodynamics course as well, SOA 570. So it's all in all, it's fairly comprehensive. We try to give a more holistic exposure to these different courses that you'll have a chance to take when you're in a graduate programs, in a master's program, whether it's by coursework or research. And, typically, I'm almost coming to an end, but typically what a student would be exposed to is they'll be taking courses. And they all will have advisors, but depending on if they're in the coursework, professional master's program, or in the research getting a degree by research, the meetings with the advisors will vary. We can talk more about that as questions arise. There may or may not be research group, lab group meetings, but there will be if you're doing a thesis option, which is the research option. Then we have opportunities for seminars where we bring in a lot of speakers. In fact, there's a seminar going on right now on a very interesting topic. So we have them weekly, and we actually try to make students take, I think, 1 or 2, correct me, Anna, if I'm wrong, hours if you're doing a master's of seminar series. There are opportunities for field work, teaching, internship, which is something we encourage. There are mentoring opportunities and opportunities for going to conferences. So we have all that. And if there is time, I'm gonna quickly stop sharing, and then I'll share this video again if you give me one moment. So I'll share the sound. So there you go. All right. Oops, I'm sorry. Should not be the case. Just give me 1 second. All right. There you go. Share the sound. And Anna, let me know, moment of truth, if the sound is working. I'm going to make it full screen. Can people see my screen? Okay. one last thing is some of you may want to know what I do. I'm not going to present anything on it, but what you can.
Oh, I think you're muted.
You turned your mic off, Faisal.
Yeah, we heard the beginning and then
Got really exciting, then you turned your mic off.
Yeah.
No, I turned my mic off on purpose because the YouTube kept running to new videos. I had to stop that. But anyway, there's something else I just want to quickly point you to. I'll just put it maybe in the chat, maybe much better. I can find the chat. Let's see. Okay. There you go. So I'll put it for everyone. So there's my website. So folks, if you want to know what I do specifically with my group of students, and there are lots of videos there. And I also am a part-time struggling filmmaker on this side, which is why I'm still teaching and which is my day job. But you can look, there's a page on cinemas. Feel free to take a look. And there's a lot of other things we do on education, starting from K to 16 all the way. So that's about me. So enough of me. I'm just going to stop here. We can take questions now, Anna. We can let Professor Brett talk. I don't know. It's fine either way.
If it's okay with you, Faisal, I'll go now, because then questions might pertain to both of us.
Yeah, I think that's a good idea.
Questions that,
and I think students can always use the chat if they have questions, so keep them coming.
Yeah, Anna can monitor the questions in the chat box.
Yep.
Okay, I'm going to take off now.
Awesome.
There we go. Hopefully I put up the right slideshow. Can you see anything? Okay, good. Okay, so one of the first things I want to say is that the reason that Professor Hussain and I speak at the same time is because there is very close coordination between the two groups, the environmental group and the H&H group. And the main reason for that is our department has a very heavy water focus. We have one faculty in the environmental and H&H area who's an air person. That's Professor Julian Marshall. But the rest of us work with water. And, there's a lot of questions that are at the interface between the two subject areas. So like one of the areas where there's the most jobs in the Pacific Northwest is issues relating to stormwater management, combined sewer overflows. And if you want to do, work in that area, then you'd probably take a mix of classes from the two subject areas, because you need to understand the behavior of water, especially in an urbanized environment. But you also want to understand all the things that are in the water that we might be concerned about. And you can also see from this slideshow that there's a couple faculty that showed up in both slide decks. And I guess you could also, probably observe that by and large, the H&H faculty are more photogenic than the environmental faculty, or at least they have newer pictures. Just to keep up with Professor Hussain and his beautiful pictures, I have a couple beautiful pictures of my own, but they don't have anything to do with research. They just have to do with my hobby. So program at a glance, this gives an overview of the kind of things that environmental engineers work with. The main thing I would say is that we work with issues related to contaminants in water, and the faculty in our department do a lot of research on contaminants related to, drinking water treatment, wastewater treatment, stormwater management, contaminants in stormwater. I do research on surface water quality, so issues related to surface water quality in lakes, rivers, and estuaries. And so we already have these, biogeochemistry. The faculty who are, listed in both slide decks are Professor Buttman, who looks at the global carbon cycle and carbon exchange between terrestrial, atmospheric, and aquatic systems. And then also Professor Becca Newman, who works with the biogeochemistry of soils and transport. And she does a lot of research also on things like arsenic contamination of drinking water sources in some developing nations. A few points, and on average, at any given time, our group has about 70 graduate students dispersed between professional masters, MS, thesis students, master's thesis students, and PhD students. There is, a strong regional job market. There is some disruption right now because of the chaos within the federal government. which is, I think probably you all realize, quite chaotic right now. And we have 3 degree tracks that you might be interested in. One is a professional degree track, which usually takes 4 quarters. It's self-funded, you pay by the credit. It's very flexible and self-paced, so it allows students to both work part-time and go to school part-time. It's not unusual. It's actually pretty common for students to work, maybe half-time at a consulting firm, and then maybe taking, maybe 6 to 8 credits a quarter while they're working, because you're paying by the credit. So it doesn't really matter whether, the cost doesn't depend on whether you finish your degree in 3 quarters or 6 quarters. You can pace it to whatever makes the most sense for you. We have a research master's program, and then what that means is that you are funded, so your tuition is paid for. You'll get a stipend. You'll have I think a pretty good healthcare program policy, and this requires that you have a project. So you have to have a professor in the department offer you a funded project, and it also requires that you complete a master's thesis, and ideally, publication, a research publication that lays out the outcomes from your research project. We also have a PhD track, and so that's typically 3 years after you complete a master's, also a funded project. And that's, a good track for somebody who wants to then have a career that's research intensive. So if you wanted to work for an organization that's heavily focused on research, it makes sense that you would do a PhD. But both the research masters and the PhD project requires that there is funding available to you. Let me see. Go to the next slide. In environmental, master's program, about half the students that come into the environmental master's program are coming from a science background. And if you're coming from a science background, there are certain classes that you went, or certain concepts that you wouldn't have been exposed to during your undergraduate curriculum that are really core to the way environmental engineers approach problems. And so one of these is mass balance and the other is fluid mechanics. So if you're coming from a science background, so that means if you're not coming with an environmental engineering degree, a civil engineering degree, or maybe a chemical engineering degree, you'd be required to take these 2 classes. And they're junior level classes, which means you have to pay for them, but they don't count towards your 42 credits of graduation. They're just a way for you to get kind of on par with the engineering students that you're going to be taking classes with. And also because all the classes you're going to take at the graduate level are going to assume that you're already very familiar with these concepts. And they're not particularly complicated concepts, but it helps a lot to have, kind of the foundational, approach to them and to have you familiar with that. The graduate school does not allow us to count junior level classes towards a graduate degree. But if you look on paper and you look at like what's required to get into our graduate program, it'll look like you have to take, a year's worth of calculus-based chemistry, calculus-based physics, and a whole bunch of other classes, statics and dynamics. And what we have found is that for you to be successful in graduate school, if you take these 2 classes and you do well at them, you'll do well in graduate school. You don't need to go back and take a whole year worth of, physics, not a calculus-based chemistry and physics and statics and dynamics to be successful in our graduate program. So we try to like streamline it so that you can get, into the program and then get on with the rest of your life, to be honest about it. Professor Hussein already showed you something like this. It's a little bit, the spreadsheet's a little bit different for the environmental group, but we have somewhat fewer required classes. I think we only have 3 required classes. The core water requirements are microbiology, aquatic chemistry, and environmental organic chemistry. The rest of them are electives. We try to work closely with students to come up with a curriculum that matches up well with what you want to do professionally. So, whether that's, to pursue a research career or to pursue a career in some type of water treatment or even air pollution if you work with Professor Julian Marshall. Some of the topic areas that our faculty work on, one of the high profile ones is there's a professor in our department that published a very high profile series of papers showing that chemicals that leach out of tires when tires weather during just normal use are extremely toxic for salmon. And so there's been this phenomena called pre-spawn toxicity, mortality, pre-spawn mortality that people have been working on for about 25 years in the Pacific Northwest. And basically what they noticed is that salmon were swimming up into these urban streams and they were dying before they even spawned. Probably most people know that salmon die after they spawn, but these were dying before they spawned. If you opened up the fish, you would see they had their eggs and they had their sperm in them, and they should have survived and spawned and then died. And so this has been a big concern in urban streams in the Pacific Northwest. And it was a monumental effort to figure out what was actually causing this. But after about 20 years of research, Professor Ed Kaloji figured out that there was a very toxic compound that weathers out of tires and is extremely toxic for salmon and actually other aquatic organisms. Professor Jess Ray does research on PFAS. So PFAS is a very active area of research in environmental engineering. They've probably heard of them. It's called the forever compounds. And so she's trying to look at methods of removing PFAS from matrices like stormwater or wastewater effluents. There's a huge concern about PFAS in what's called biosolids. They take the solid, residuals from wastewater treatment, and they oftentimes apply those onto forests or non-food crop soils. And there's a considerable concern nowadays that these forever compounds will then contaminate the soils. She does a lot of stuff on, sustainability, water resources in urban environments. Stormwater management is a very active area of research for her. And she teaches a class on physical chemical treatment processes. Stormwater management, I already mentioned. Professor Dodd does a lot of research on oxidation, disinfection processes. So he's interested in things that could be problematic in drinking water systems. How do we treat our drinking water so that it's safe for us? And urban water reuse, requires a lot of, especially high-end treatment so that we can take that water and reintroduce it back into either non-potable uses or if you're in a more arid climate, potable uses. We're not talking about reintroducing treated wastewater into the potable, the drinking water supply in the Pacific Northwest yet, but there's a lot of talk about taking, treated wastewater and using it for irrigation and industrial uses and coming up with treatment schemes for those sorts of applications. Got some pretty fancy slides here. There's a lot of field trips that you have an opportunity to do, field trips to wastewater treatment plants, drinking water treatment plants, stormwater treatment facilities that you'd have opportunities to participate in. Professor David Buttman is one of these hybrid faculty who's both in the H&H group and the environmental group, and he studies the global carbon budget. He's also a faculty in the School of Environmental and Forestry Sciences. We have a couple faculty in our group that are in multi-units in the University of Washington system. So he studies a lot of issues relating to the global carbon budget and especially carbon exchange between aquatic systems and in the atmosphere. So just some slides from him. I'm not sure if I have a whole lot to say about him, but mainly, carbon exchange with aquatic systems in the atmosphere. Professor Gregory Korshin does research on physical chemistry, so issues related to corrosion. He's got some big projects right now in arsenic contamination coming out of landfill leachate. And he does also a lot of research on dissolved organic carbon in drinking water supplies. That's a considerable problem in drinking water treatment systems because the dissolved organic carbon interferes with the disinfection process. And it also creates disinfection byproducts called trihalomethanes that are carcinogenic. So ideally, if you have these dissolved organic matter compounds in your drinking water source, you want to figure out a way of getting rid of it before you do conventional drinking water treatment. So here's some of his projects. Got a lot of slides here. Here's a slide of me. I do research on lakes, rivers, and estuaries. And so this, my senior level class has to do with eutrophication, cyanobacteria blooms, hypoxia, lake restoration. And there's just two pictures of two lakes, which are coincidentally about 25 miles apart. And the really beautiful lake, so that's Crater Lake, one of the most beautiful lakes in North America, is actually the main water source for Upper Klamath Lake, which is one of the most degraded lakes in North America. So there's a fascinating story how the most beautiful lake in North America can be the source of water for the most degraded lake in North America. It's really kind of a fascinating story, but I'm assuming we're not going to be here for 2 or 3 more hours, so I won't be able to tell you all the details of that story. But if you take my class, you can hear about it. Microbial process fundamentals, we have Professor Mari Winkler in our department. She's a world authority on the nitrogen cycle, and particularly the nitrogen cycle in wastewater treatment, how you can harness microbes to convert nitrogen to a more or less inert form. If you can take, inorganic nitrogen or organic nitrogen, turn it into inorganic, and then turn it into gaseous nitrogen, you've basically converted it into a form that have much, much smaller environmental impact. I mean, the atmosphere is 78% nitrogen. So if you can turn it into nitrogen gas, you're pretty much you got rid of it. And so she does a lot of research with methods that you can implement to enhance nitrogen removal in wastewater treatment plants. Some really sophisticated methods where she's kind of the, one of the world authorities on how to design these technologies to get the nitrogen down to much lower levels so that we don't have, algal blooms and eutrophication problems in receiving water bodies. Aquatic chemistry is one of the classes taught by Professor Korshin. Is just a very deep overview of the chemical principles in aqueous media, physical chemical treatment processes, how do you get stuff out of water? Environmental organic chemistry is, all the organic compounds that can be found in water, and how would you, try to, knowing the attributes of those compounds, how might you remove those? What might be their environmental impacts in aquatic systems? I have historically been teaching a class in mechanistic surface water quality modeling, and Professor Ray teaches a class in advanced topics in environmental engineering, chemistry, and biology, and also related to treatment principles. We have a class in air quality management taught by Professor Julian Marshall. So he studies air quality, especially in developing nations, but also in the United States. And he does a lot of research on social equity issues, like which populations are exposed to the worst air quality. How does that relate to, people's socioeconomic status within the country, and then how does it, vary globally? Because we know we have air pollution problems in the United States, but there's some parts of the world that have air pollution problems that dwarf ours. Some of the places that graduates from our department work is a lot of the different consulting agencies in the Pacific Northwest. We have a very good representation. I would say, like, of the environmental engineering consulting firms in Seattle, probably 20-30% of the students working for them have come from our department. So there's a fantastic network that you can tap into and try to figure out which firms out there are doing which kind of work, and it's easy for us to connect you up with our grads from 5 years, 10 years ago, and introduce you to them, and they can give you kind of the the inside scoop on what's going on with their companies. What are they working on? Are they hiring? What's going on with them? We also have sent people to a lot of agencies, maybe these days not quite as many federal agencies because the federal government is completely dysfunctional. So that's just an opinion of mine. But the state agencies are very healthy right now. So we do a lot of research in our department with King County. Supports quite a number of projects in our department, and also hires a lot of our graduates. But we have our graduates going to, water treatment agencies in different states. Department of Health, WashDOT is also very interested in issues relating to stormwater management. And then we have some of our recent grads have gone on to faculty positions at branch campus of the University of Washington, Oregon State, Stanford, probably a few other places that I'm not immediately aware of. And I think that might be my last slide. I probably should have given you the last slide, should have been my fish pictures. But now I guess we can entertain any questions you might have about our programs.
Yeah, it looks like we already have a couple in the chat. And one thing I might just add, kind of building off of the end of your presentation there, Professor Brett, was we have a career fair every autumn quarter where we have like over 100 employers, and a lot of our students find jobs that way. And I was just meeting with our like Career Center at Engineering. And they were talking about how all of the students in our department are actually like having no issues finding jobs, whereas like I think a lot of the other sort of engineering or other STEM areas are noticing some challenges for students. So for the time being, I would say the job outlook for our grads is like actually very strong. I don't know if you guys have anything else to add on that.
Well, probably a lot stronger than a lot of other areas.
Yeah.
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 Technology is not so good. It looked really good a couple of years ago, but it turns out that they think they can replace everybody with AI.
Yeah.
Yeah.
So
We're
I
not there
wanna
yet.
echo Professor Brett, like comparatively, compared to computer science and other fields, I think our job, our employability of our grads has remained held steady because the end of the day, you still need someone to, apply the knowledge hands-on, know how to do irrigation systems, manage dams or treat the water, all that, which, fortunately, AI has not figured out how to automate completely without human beings. So that's looking good.
Awesome. So a couple of questions already in the chat. So there's one student who's saying they earned a bachelor's in agricultural engineering and a master's in environmental engineering, where their thesis focused on modeling the effect of industrial effluent on surface water using HECRAS. Given this background in hydrology and pollutant transport modeling, would they be considered a strong fit for the environmental engineering option at University of Washington?
I would say they'd be a strong fit for either environmental or H&H. We do actually teach HECRAS in our department, and that matches up with the kind of work that a lot of people in this department do. So I think it would be a good fit. Professor Hussein, do you want to?
No, I mean, your answer's fine. I agree.
Thank you. Yeah, making a mental note that it's HECRAS.
Oh, that's okay.
Yeah,
Okay, and
we
then
also expose students to other kinds of software as well. HECRAS was just an example. Like there are these Bentley or EPA standard softwares called Bentley systems that we expose to. So students do get exposed to a lot of industry standard softwares.
okay, great. And then, so we have another student who says, I'm interested in the H&H program. How likely is it that a foreigner will get a good job in the US after completing the grad program? What is the approximate graduate employment rate?
So maybe I can try to answer and then others can fill in. So historically, we've had international students, we've had local students. There hasn't been any issues with employability, everything. But right now, this year, you probably know we're in a very interesting, unique time, especially for international students and all that. So really can't say a whole lot. I mean, I have a few students who are graduating soon. Some of them have landed jobs, some of them have not, and they've gone back. So it's a mixed bag, but historically, yeah, there's been no issues. The job markets look strong and they have gotten jobs. Now, about the time frame, if you're doing it by thesis, what was the specific question again? What is the approximate graduate employment rate? I'm assuming the student's referring to the time taken, or is it like what percent of our students graduate?
My interpretation was like what percent of the
Okay,
graduates
employment
get,
rate. Okay, they're
yeah.
getting jobs. Yeah. I mean, historically, there hasn't been an issue. Like, at least I can speak for our past students who've graduated, my former students, they're all doing something. They all have a job, whether it's faculty jobs, some of them are in research centers, federal research centers, some of them in charity organizations, development organizations, state agencies, So it hasn't been an issue right now. And like we mentioned, especially these days, hardcore engineering, such as what's taught in H&H environmental, actually they're looking pretty good compared to a lot of the data AI-based, you know, disciplines that you have out there in CSE computer science. So I think we're good. I would say 100%, right, Professor Brett? Employment rate?
I think the job prospects have been really good. It's just there is some uncertainty right now. Some of the firms are just trying to make sure that if they hire somebody that they'll have the projects for them, because there's, you know, maybe the worry that if some project is indirectly supported by federal money, that the feds could yank it.
Yeah.
That, you know, there is a bit of uncertainty. And I think that's probably, you know, across the board and, you know, for anybody in this field. And it's certainly, you know, widespread in academia. And I also asked about, you know, getting into the thesis program as an international student. Historically, that was no problem. Historically, we have a very high proportion of international students in our graduate program. There are some issues with visas right now. Maybe Anna knows more about that than I would know. But the federal government has denied visas to some, you know, students from some countries. That has been happening.
I would say from what I know, there are some, I think, very specific countries that are having trouble getting visas. But I think like the overall rates, the majority of students, international students, have been able to get a visa and come here. I think a lot of the challenges are also just like delays in the process, from my understanding.
Yeah.
Yeah.
And then,
So the majority of my students in the thesis program are all international, and historically, there's never been an issue for them getting visas. Even recently, like a few months ago, they've all gotten visas. So we haven't faced any issue of that nature.
Yeah, and then so moving on, because it looks like we have a couple more questions popping up, which is great. So for the H&H program, are fieldwork opportunities available for PMP students or mainly thesis students?
Actually, both. I mean, it's a great question. So if you're in that non-thesis, you know, PMP program, there are a couple of courses that you could take, such as snow hydrology. And there's a coastal course where I know actually as part of the course, you do actually have to do some field work. You go to this place called Stevens Pass, which is nearby in the Cascade Mountains, to go do some field work on snow and all that. Plus, you know, if you have an interest, anybody, whether you're in the PMP or the thesis program and you want to be part of a field work, or we do a lot of field visits, we don't mind others tagging along with us. You know, we actually, a lot of undergrads do that with us. So just let the professor know and work it out if that's what you want to do, see some interesting places nearby.
yeah, I wanted to touch on, you know, follow up on what Anna said, then get to what Lucy's question is that so far, you know, the federal government is not being very nice to universities. It's trying to like take universities down a notch or two, but they're not being worse to our university than to others. So far, we're not like, you know, on the top, you know, 5 of their targets. So we're dealing with issues that everybody else is dealing with, but it's not worse here than it is other places, at least not yet. You know, they seem to be focusing more on East Coast universities, and on the West Coast, they're more fixated on UCLA right now than they are on us. So hopefully, you know, I mean, we have somebody in leadership who has a very short memory, and sometimes he forgets he wanted to invade Greenland or they want to take over Panama. So hopefully he forgets about this in a few months once something else comes up. Lucy had a very good question about, you know, whether there's going to be funding for the 2026 cohort. It is true that some departments at the University of Washington have, in the short term, decided not to admit any new students so that they can balance out and make sure that they can follow through on the commitments they have to students that have already accepted. Our department has not made that decision. We haven't needed to yet. So if we have funding available, we will accept new students on funded projects. So we're not there yet. So far, we're taking in new students. Probably not taking in as many as in years past, because there has been, you know, some people have lost projects. There are fewer RFPs, requests for proposals out there. So that the situation is not as, you know, not as favorable today as it was a year ago. But we haven't stopped accepting students, and I don't anticipate that we will. I think we'll keep on accepting students, probably less than what we have in the past, just because there's, you know, a lot of people are supported by federal money, not everybody, but, you know, probably half the grants in our department are traditionally supported by federal support sources. And that's down, you know, there's no, but it's a down, you know, across the board, you know, in the whole country, not just us.
Yeah, one thing I think Lucy is referring to is thesis-based masters. So I mean, normally thesis-based masters funding, I mean, we normally fund for PhDs in our program, like, you know, if it's from a sponsored project or something. So you're not, like Professor Brett, you might be able to correct me if I'm wrong. We're not actively recruiting thesis-based masters per se and providing them funding. We usually do it for the PhD program, but if it works out, it's fine from the project.
It does happen sometimes, just because there are times when the project is only going to have 2 years of support, and you know that from the beginning. You know, whoever the funding agency says, you know, we envision this as a 2-year project. We got a specific question we want research done on, and we don't anticipate, you know, turning this into a 4-year project. And if it's, you know, going to be a 2-year project, then you're going to offer it to somebody for a master's. And if all goes well, maybe some other project comes along, and if that person's interested in doing a PhD, then they could continue on with their research. But you know, it may also be that money is not available after that 2-year period, and then somebody completes a master's and goes out into the workforce.
Yeah, in our H&H, that's pretty uncommon. We mostly prioritize the PhDs for our 3 to 4 year, 5-year projects we have. But like Dr. Brett said, you know, it still happens sometimes. You have to just, you know, do a master's, maybe have funding available for a master's. Just wanted to let you know that it's not as common, or like we don't have a big pool of funded master's students in our program.
Anna asked about the TOEFL. Anna, can you answer?
Yeah, I was gonna say, so how important is the TOEFL score in the admissions process? I would say as long as you're meeting the, like there's usually like a minimum score set by the graduate school. And if you're meeting the minimum score, how far you are above that does not really matter. It's more of like checking a box. Do they meet the minimum? Yes. And then there's also a minimum score if you end up with a TA-ship, if you're doing the thesis track. So if you don't meet the minimum for the thesis for the TA-ship, you can usually take like a couple of English classes to kind of get you up to speed before you start teaching. So that's not usually a problem either. So basically, as long as you meet that minimum, it doesn't really impact your application. Let's see. And then we have another student who said, I had my bachelor's in civil engineering and master's in information systems. Now I am applying for a PhD in environmental engineering with only research experience I have as my capstone project. How good is my profile suited for this program?
Can I take this one, Faisal?
Sure.
So the one thing I want to say, and this is a super important thing that you know about our funded research projects, is decisions on who is going to be offered funding is always made at the level of individual faculty. So each individual faculty will write proposals, and when proposals are funded, then they'll look for the student that they feel like would be the best fit for that project. But that decision is always made by individual faculty. So Professor Hussein decides who's going to work on his projects. I decide who's going to work on my projects. That's not a decision that's made by the administration or the department or even other faculty. So if you want a funded project, it's always very important that you establish a dialogue with the faculty in the department that's most likely doing the research in the areas that you would be interested in. So those decisions are, like, with the exception of just a couple of fellowships, we give out maybe 5 or 6 fellowships that you might be able to compete for. 90% of the students are being the first year funded off a research project. And that's always a decision made at the individual faculty level. So to get a funded research project, you need to establish that, you know, communication with somebody and, you know, explain what your interests are, and they'll explain what funding opportunities they have. And then you'll try to figure out whether those two line up. And that's the way it works in our department. It could be slightly different in some other places. It's even slightly different in structures. because in structures, they bring in like a cohort of like, 6 or 7 students. And the first year they're just doing, not just, but they're working as TAs. And then after the first year, then they start assigning them to specific research projects. We don't have enough TAs to like fund like, 10 students coming in, the first year off of TAs and then assign them projects after that. So we make the decision of which student's going to be supported by which project upfront. And so that's a really important thing to understand about how our process works.
Thank you. A question for Professor Hossein. You guys mentioned that in environmental engineering, many students do not have an engineering undergraduate degree. Is this true for the hydrology and hydrodynamics students as well?
Yeah, I mean, yes. I mean, I don't know the numbers, what percentage, but I can tell you, like, I have a few of my own students that I'm advising, and they're not from a mainstream engineering program. They're from geophysics or geophysical technology or something else. So at the graduate level, actually, it varies. So not all of them are engineering majors at the undergraduate level. And the more the diversity, the better, I guess, for our program.
Great. And then another question for you. Is it common for master's students to be funded by RA/TA positions in H&H?
So kind of with that caveat that funded master students is not really the norm, or unless there's a situation arises where a professor is actively looking for just a master student to fund from their sponsored project, because it's probably a 2-year program. Then it would come from the research project funding. But if you say TA and RA, as Professor Brett mentioned, we don't really have a lot of TA positions. In fact, we changed our policy recently, so they're mostly grader positions now. So yes, if they were to be funded, there would, I guess, would likely be RA positions if the professor or the major advisor has kind of like those type of projects, 2-year projects where he or she is looking for a master's student.
Yeah. So what often happens with TA positions is if a faculty is supporting a student on a project and the project, maybe it takes 3 months longer than anticipated and the student hasn't finished up their thesis yet, then maybe they would be put on a TA position for that 3-month period to help them like kind of just wrap up the final details of their thesis. So most cases, the first preference would be to take a student that's already funded and put them in an RA position, a TA position, I mean. But there are cases where, sometimes we just need somebody to TA a class because the students that have research projects are, they're funded and they want to put all their time into the research project and not into being it, because the TA is a big commitment. Some of the classes that require TAs, they're large. I'm teach a class called junior level class called environmental engineering for the civil engineering students, and that class is going to have 120 students. So it's a busy class. So some of those opportunities come up, but they don't come up in a obvious enough way that we can promise them ahead of time. So there are plenty of people that end up being TAs that do get pulled out of like the professional master's pool to TA for a quarter or two, but we don't traditionally promise those 6 months or a year ahead of time, because usually the first preference is to see if a student who is short on funding but wants to finish up a PhD could benefit from being a TA. And also, if somebody is interested in the academic track, being a TA is very beneficial, for their resume, so that they can show that they have some teaching experience.
Thank you. Yeah, I think this will be our last question. If I want to explore a career in river, stream, or groundwater restoration, would the CEE or H&H department make more sense? And
I can quickly answer that. Yeah. I mean,
Yeah.
I think the Virginia mentioned maybe ENV and H&H probably because we're all in the CE. Yeah, I mean, it could be either, it could be both. Like Professor Brett mentioned, we have a lot of overlap. So, groundwater restoration, river stream restoration, it may involve water quality issues, contamination, all that, or something more physical. You have that wiggle room where you can take courses, electives from different areas, both within CE and outside. So definitely CE would be a great home. And if you do it under H&H or ENV, it really doesn't matter. Probably H&H might make a little bit more sense, but it depends on what specifically the student's looking for.
Yeah. Well, I do that kind of stuff, and so does David Buttman, and he's one of the people that we listed in both groups. And so does Professor Becca Newman. We listed her in both groups. And then Professor Ed Kologi is the one that discovered that toxic compound in tire leachate. So there's 4 of us that work on it, and we're all kind of, you know, I think there's a lot of overlap in that particular subject area between H&H and the environmental faculty. So, you know, and also, you know, a lot of the jobs are related to stormwater management. So what you're talking about, river, stream, groundwater, stormwater is a huge issue. And it's lots of opportunities for employment there. And that's, I think, right smack dab in the middle of the 2 fields. And so, you know, one of the things too is that we have a seminar series, and the H&H and environmental faculty get along so well that we have one seminar series. We don't have separate seminar series. In many ways, our 2 groups are very closely aligned. We have, like, you know, monthly meetings where we're all together, the H&H and environmental faculty. The only thing that where we are truly separated is the admissions process for our graduate students, and in each group has a different cohort. But it's often the case that when I'm looking at people that applied for the environmental group, they say they want to work with Professor Hussein. And I'm like, okay, you know, you slightly misunderstood the structure, but I'll send this application over to Professor Hussein, and he'll read it and he'll make a decision. That happens all the time, you know. So I like to think of the 2 groups of being very closely aligned, and we don't have any border between us. You know, conversely, it's not very likely for students in our groups to be taking a structural engineering class. I'd say not very common in my 25 years. I've never heard of it. So almost never, you know, and maybe, you know, in transportation, there's much less overlap with us, but between these 2 groups, there's considerable overlap. And it doesn't really matter who you work with. I mean, it doesn't really matter which group you're with. It matters more which faculty advisor you're aligned with. That's more important.
Yeah, and I have had students switch like in their first quarter of the program, like they get in and they're like, oh, I was doing environmental, but I think I'm actually like a better fit for H&H for our professional master's program. And that's usually something we can accommodate if, you know, if that were to happen. Um, okay, well, it looks like we're kind of out of time. But the last thing I will say, if you have more questions, please email me/us at ceginfo@uw.edu. I'm putting that in the chat. And my guess is most of you already have that email address if you found your way here. But we can always set up, we set up one-on-one advising appointments with prospective students. So if you have more questions, we can set up an appointment. We can answer your questions over email. We are always happy to chat. And with that, I would say, everybody, let's thank Professor Hussein and Professor Brett for taking the time to join us tonight. And good
Thank
luck.
you, Anna.
Yeah,
thank you for showing up too.
Yeah, and thank you everybody who showed up.
Yeah.
Appreciate it. Yeah.
Thank you so much.
And
And your
good luck
questions.
on your applications.
Yeah.